Hello and welcome to a discussion on identifying when rational expressions are undefined. So undefined rational expressions are when the denominator of a rational expression is equal to 0. So that means that the denominator would be 0 with anything on top, making it undefined. Okay, looking at some examples. We have examples, what values will have the rational expression become undefined? So the procedure is to take the denominator alone, leave the numerator by itself, and set it equal to 0 and solve for the variable. So set the bottom equal to 0. That's our first step. And the second step is to just solve for variable. So this right here, we've taken 5x, which was the denominator of 2 over 5x, and we've set it equal to 0, so we have step 1 complete. Now, to solve for the variable, noticing 5 and x are beside each other, meaning that's multiplication, so we do the inverse operation of dividing. So we divide by 5 on both sides to get x by itself. So x is equal to 5 divided by 0 divided by 5, or just 0. So that means that the rational expression here, this fraction, will be undefined when this x is 0, because that would be 5 times 0, making the bottom 0. Okay, continuing our same pattern, let's just take our denominator of the fraction x minus 2 over 2x plus 5. So we're just going to capture the 2x plus 5, and we're going to do our next step of equaling it to 0. Now we have to do the final step of just solving for the variable, which is right here. So to do that, we first have to do the opposite of this 5, a positive 5, so we subtract 5. So we're going to be left with 2x equals 0 minus 5, or just negative 5. Now to get x by itself, you have to notice that 2 and x are beside each other, meaning they're multiplied together. So to break them apart, you do the opposite of the multiplication, which is division. So you divide 2 on both sides. So you have x is equal to a negative 5 divided by 2, or negative 5 halves. And when you plug that in for x in the original equation, it will make the denominator equal to 0, making the rational expression undefined. Okay, looking at this next example, we have the rational expression x squared plus 2x plus 4 all over 5. So what you do is just capture the denominator and set it equal to 0. Now what you need to realize for this is that there are no variables. So we have to see a statement. Does 5 ever equal 0? It does not. So that means that there is no number that will make the fraction undefined. So this is never undefined. And that is the answer for this problem. Nothing will ever make that rational expression undefined. Okay, looking at number 4, we have the fraction 2x plus 4 all over x squared plus 3x minus 4. So again, just capture the bottom of the denominator, say x squared plus 3x minus 4, and the step is to set it equal to 0. Okay, so for this we want to try to factor, since we really can't do anything else with our problem. So to factor, we see that 1 has a coefficient of 1, meaning we can just go ahead and set up our 2 sets of parentheses, putting an x as the first piece in each set of parentheses, because we would get x squared with a coefficient of 1 when multiplying across with FOIL. Okay, now we use the sign. Remember, if it is positive, we use the same sign for both from the second term. However, this is negative, so that alerts us that one will be positive, one will be negative. Okay, now we have to say negative 4 What numbers can we multiply together to give us negative 4? That could be negative 1 and 4. That could be 4 and negative 1. That could be 2 and negative 2. And remember, 2 and negative 2 and 2 would not matter because the signs would be the same no matter however you arrange them. Okay, so these are things that multiply to give us 4. Now, what could we combine together through adding that would give us the positive 3? And if you look, the 4 and the negative 1 would give us the positive 3. So let's put 4 with the plus, and let's put the 1 with the negative, so we retain our negative 1. And since both terms are now equal to 0, we can set them apart, saying x plus 4 equals 0, and x minus 1 equals 0. Okay, so our next step is to solve for the variables. So for this first one, subtract 4 on both sides, leaving with x equals negative 4 as a solution. And for the next part, add 1 on both sides, leaving you with x equals a positive 1. So this actually has two numbers that can make the denominator undefined.